All right. All right, I'm waiting on a few people to turn their screens flat, and then we're going to get started. Will, can you put your screen flat, please? Oh, now you're in the video. There we go. All right, ladies and gentlemen, we are going to continue our work with fractional expressions, and now we're looking at adding and subtracting fractions. And this beginning intro is probably the most important and most helpful to help you understand adding and subtracting rational expressions well. So let's jump in. Consider the following numeric fractions. Would you simply multiply the two denominators together to obtain a least common denominator? Would you guys just multiply this by 4/4 and this by 16/16? Would that be the least common denominator between 4 and 16? No, what's the least common denominator between 4 and 16? Should be 9/5. So what's the least common denominator between 4 and 16? So the smallest number that divides into 16 is 4, but the least common denominator would actually be 16. And I think I heard 4 because we would multiply this side by 4/4 to obtain that 16. So hopefully your answer was no, don't just multiply 4 times 16. There's a smaller common denominator than 64. What would it be? 16. You picked this because 16 is the smallest number that 4 and 16 would multiply into. Take this problem again, and I'm going to zoom in on it because if you can understand this, hopefully the rest of the lesson will be easy for you. Take that problem, 3/4 plus 3/16, and consider expressing it as 3/4 plus 3/4 squared. Can you see that the least common denominator simply contains enough 4s so that the largest number will multiply into it, in this case 4 squared. So I noticed that there's a 4 times 4 in 16, and so I'm just missing one other 4 over here. Now take that concept and take it to a higher level expression now in Algebra 2. Think about the following. State the least common denominator, and I always abbreviate this with LCD. So state the least common denominator for each. So if I'm looking at this expression, which has x minus 1 and x minus 1 squared, what's the least common denominator between those two? Perfect, x minus 1 squared. It's just like looking at it as 4 and 4 squared. So I would have to multiply this by x minus 1 over x minus 1 in order to simplify. We won't simplify that one. We're just kind of seeing, hey, do we get what a least common denominator is? Let's look at this next one. If you have 2x minus 1 squared, 2x minus 1 cubed, and 2x minus 1, turn to your partner and see if you can tell them what would be the least common denominator for this expression. I heard it. Christian, can you tell me?
2x minus 1 cubed.
Perfect. 2x minus 1 cubed. Because this is the highest one, I would need 2 more factors, 2x minus 1 squared for this one. And I would need a 2x minus 1 over here for this one. Okay, we're going to start with the easier stuff where you're already given a common denominator and you have to see how do I add and subtract the fractions. And then we're going to use that skill to obtain a least common denominator. But here's part 1, adding and subtracting with common denominators. So looking at example 1, if the denominators are the same, you just combine the numerators. So this would be x plus 2x over 9. Can I combine x plus 2x?
Yeah, 3.
Awesome, 3x over 9. And the last thing I do is reduce. A fraction is reduced when all the common factors have been canceled from the top and the bottom. So what can we reduce here? Yes, we can divide by 3. 3 goes into itself one time, into 9 3 times. So our answer is x over 3. Are there any restrictions in this problem? No, because 9 is not a variable. It can't equal 0. So the answer would just be x over 3, and my restrictions would be 9. Molly, Sergio, do you guys have something to add to it?
No.
All right, on to example 2. Example 2, the denominators are the same. So we just combine the numerators. This time it's subtraction. So we would do 12 minus 2 over xy cubed, which would just give me 10 over xy cubed. But does this one have restrictions?
Yes.
Yes. What can x not be? Good. And what can y not be? 0. Perfect. So this one, I would have the answer with my restrictions labeled 10 over xy cubed such that x can't equal 0 and y can't equal 0. All right, let's keep working, but let's advance the examples a little bit more. Example 3, do they have a common denominator? Yes, so we can combine the numerators. Let's go ahead and combine them in a single step. What's 6y plus 3y? 9y. And what's negative 4 plus 1? Negative 3. Good. And then I still have this y squared minus 5. What'd you say, Liana?
Oh, I was thinking ahead, sorry. I was saying like the plus minus, but yeah.
Oh, that would be really good if 5 was 25. Then I'd want to go y plus 5, y minus 5. Yes. So always a good thing to check for. Do we have the difference of 2 perfect squares? But this does give us a restriction. Does anybody know what the restriction would be for this problem? Cynthia?
Is it y equals 5? Or y is not equal to 5?
You're close. You're super close. Min?
Is it
Y does not equal plus or minus root 5.
Oh, you could look at it like that. Okay, so Min is saying y cannot equal plus or minus root 5. If you gave me that answer, I'd say great. You could give me a less simplified answer. I'd still accept it. Min, how did you get that answer? It's really good. Did you just think about what squared minus 5 would give me 0? Yeah, that's good. That's perfect. Another way, if you didn't quite think about it in that way, you could just go ahead and say y squared minus 5 can't equal 0. The piece that you have to see is the minus 5 is connected with the y squared. Now I can show you how mathematically we could check out that Min's way is correct. You could add 5 to the other side, and you would get y squared can't equal 5. Take the square root, and yes, we see y cannot equal plus or minus root 5. Now your restrictions, you could write in the way that Min thought about it, y can't equal plus or minus root 5, or you could just say y squared minus 5 can't equal 0. Either of those are good. You're telling the reader that the denominator, those two pieces are terms, so they're connected, and they can't equal 0. So this would be my answer, 9y minus 3 over y squared minus 5, and these would be my restrictions. All right, on to the final example, example 4, and this one is really tricky. I'm going to have you like add an exclamation point with something. Ezra, come on, man, you got this. I know, it's still early. You got this. Ezra, you probably know. If I'm subtracting this numerator, what do I have to do with the negative?
I'm not sure.
Oh, what do I need to do since there's a y minus 5? Does anybody know?
Wait, don't you have to make it positive?
What do I have to make positive?
The subtraction sign.
Excellent. I knew you knew. Y minus 5 is considered one value. It's two terms connected together. So I would say add parentheses around two terms, especially in the case of subtraction. Because Ezra looked at it and he's like, oh, wait, that negative is going to become a positive. He's correct, because when I subtract a parentheses, I have to distribute that negative. So the denominator is already the same. It's 2y. But then I have 7y plus 1 minus y minus 5 that I need to simplify. So I'm going to go ahead and distribute that negative, which will give me 7y plus 1 minus y plus 5 all over 2y.
Wait, isn't that, wouldn't it be like negative 7y?
So the 7y, there's no negative in front of it, so I don't have to change it. But if there was, I would have to change it. But 7 comes first, so I don't have to change the sign. It's really the one that comes second that we have to distribute the negative to.
Yeah, but since there's not one in front of just the y, wouldn't that be 6y?
Oh, you're saying we can simplify? You're so right. I'm not done. So you're right. 7y minus y will create 6y plus 6 over 2y. Is this expression fully simplified? No. What can I reduce? Excellent. A 2. You could take a 2 out of the 6y plus 6, which would create 3y plus 3 all over 2y. Now, remember what I said Wednesday. You can reduce factors, not terms. So I can reduce those 2's. Cynthia,
Can we not just take the 6 out
the 6 out.
at the top?
So what you could, another way that you could do this is you could say take 6y over 2y plus 6 over 2y. I mean 6, yeah.
Wait,
Is that not what you're asking? So you could do that, and then you could call that.
I'm saying instead of dividing it by 2, why don't we just take the 6 out?
Why don't you just divide the 2 into both of the 6's?
Oh, never mind, you're getting rid of the 2. Never mind, I didn't see that.
You could do that though, because my full answer is going to be 3y plus 3 over y. So that would work. But then guys, what would be my restriction? Excellent. Y can't equal 0 because that's in the denominator. So this would be my answer with my restriction. Emily,
How did you get 3?
how did I get 3?
Yeah.
Because I divided 2 into 6.
Well, can't. On the bottom would be 3.
Oh, I have no idea. That was a total mistake. Sorry. Sorry. That was way wrong. Thank you, Emily.
And can the Y's cancel out?
So the y's could cancel if you broke it up. If you called it a 3y over y plus a 3 over y, then you could technically reduce the y's and call this 3 plus 3 over y. That's equivalent, but it's not necessary. This fraction is simplified because there's no common terms in the top and the bottom. This right here is connected by a plus sign. So I can't just cancel these 2 y's right here, because then it would turn into a 3 plus 3, which is 6, which is not equivalent to. So it's a really good thing to make note of. Any plus signs or minus signs, think of them like glue. They're gluing the 2 together. All right, on to questions that don't already have a least common denominator. Here's some steps to follow. Number 1, factor the denominator. This is huge to help you obtain the least common denominator. If you don't do this step, you will get some crazy work. I'm not saying that it can't be correct by the end, but it will be way harder. Number 2, establish the least common denominator. Then multiply out the fraction, multiply the fraction numerators, add the resulting fractions, factor, and simplify. Here's something that's been coming up a lot, but I don't know if we've fully written it down, defined it. A fraction is simplified when all factors are reduced from the top and bottom. So make sure you know that, because you might be looking at your work and saying, am I done? Here's how we know we're done. A fraction is simplified when there is no common factors in the numerator and denominator. All right, so let's go ahead. We're going to start a little bit simpler and then move to a little bit more advanced. Example 5. The first thing we want to take a look at is what would be the least common denominator between 5x squared y and 10xy squared. We'll start between 5 and 10. What's the least common denominator between 5 and 10? 10, good, because it would be 5 times 2. What's the least common denominator between x squared and x? X squared. And then how about between y and y squared? Y squared. So this is what I need to obtain on both sides. What do I need to multiply this first fraction by to get a 10x squared y squared? 2y, awesome. 2y over 2y. And what do I have to multiply this fraction by to get a 10x squared y squared? Good, x over x. So now I'm going to multiply those numerators, 12y over 10x squared y squared plus 5x over 10x squared y squared is equal to, now I like to check, do I have the same denominators? I do. So now I can combine those numerators, 12y plus 5x over 10x squared y squared. What would be my restrictions? What can x not be? 0. And what can y not be? 0. Perfect. So I know I have a little box for restrictions there, but this would be our answer. 12y plus 5x over 10x squared y squared. I cannot cancel the y's because of that plus sign. I cannot cancel the x's because of that plus sign. All right, let's move a little bit more advanced. Example 6. What did I say is the best first step? Factor the denominator. So looking at the denominator, what's the first step in factoring? GCF. What's the GCF between x squared and 3x? X, good. So I have x times x minus 3. And then let's look at the next denominator. What's the GCF between 3x and 9? 3, good. So I have x minus 3. Now, here's how I like to find the least common denominator. I just choose one of each factor. So x minus 3 is a factor because it's being multiplied. 3 is a factor, and x is a factor. I don't need to highlight x minus 3 again because I only need one of each. So my least common denominator is 3x times x minus 3. That's what I want to obtain in both fractions. What do I need to multiply this fraction by to get that least common denominator? 3 over 3, good. What do I need to multiply this fraction by? Good, x over x. Now I multiply the numerator, so 3 times 4 is 12 over, and I like to check, do I have the same denominator? Minus, multiply the next numerator, 6x over 3x times x minus 3. Are the denominators the same? Yep, so we can now combine the numerators. 12 minus 6x over 3x times x minus 3. Is this fully simplified? No, what can I divide out? We can divide the 3 from the 6, good. So if we take the 3, I could divide it away from the 12, which is a 4, from the 6, which is a 2, over 3x times x minus 3. Remember what I said in the previous notes, you can only cancel factors. Those are numbers that have been multiplied. So now I can cancel those 3's. And, oh, I can cancel more than that. No, I can't. That's as far as I can go, sorry. So I see that I can take out a 2, this is a good thing to talk about. I see that I can take out a 2 from the numerator, but it doesn't cancel with anything in the denominator. So I don't have to. The fraction is fully simplified. It's 4 minus 2x over x times x minus 3. Do I have any restrictions? Good. X can't equal 0 and x can't equal 3. Because if x was 3, that parentheses would give me 0. And if x was 0, the whole denominator would become 0. So this would be my final answer. All right, 2 more, a little bit more advanced examples, and I think we're ready to practice. Molly.
So is it only when there's a plus sign that you can't
Yes, a plus or a minus.
Wait, so why don't we cancel?
Why what?
For the 12 minus 6x, why did you cancel?
Why can I cancel the 3?
Oh, wait, never mind.
Because I made it like without a plus. I took it out. I made it into a factor, the 3.
Okay.
All right, on to example 7. Example 7, what is the first step? Factor. What does x squared minus 25 factor down into?
X plus 5 and x minus 5.
Nice, x plus 5, x minus 5. How about the next fraction? Let's go through it. Let's walk it step by step. The last term's positive, so am I going to have the same signs or different? Same as the middle term, plus and plus. X times x would give me x squared. What times what would give me 5? 5 and 1. Awesome. Okay, I want you to look at this denominator. Turn to your partner, the person with the darker colored shirt in the group. Tell them what you think the least common denominator would be. Write it down once you guys have confirmed it.
Well, x plus 5 times x plus 5 times x plus 1, I guess. Which I don't really want to factor that out, so.
Good, and the next one.
It's probably gonna be like x plus or minus 5 or something.
Yeah.
Are we supposed to, like,
I was just asking what's the least common denominator.
do we like multiply?
But yeah, now we got to multiply it all out. All right, guys, I'm seeing good things. The least common denominator, you want one of each factor. So x plus 5, x plus 1, and x minus 5. That would be your LCD.
Oh,
So I'm going to go ahead and just say that it's x minus 5, x plus 5, x plus 1. And now I have to multiply each fraction to obtain that. So what would I have to multiply this fraction by? What's missing out of x plus 5, x minus 5, x plus 1? X plus 1. So we're going to multiply this one by x plus 1 over x plus 1. What's missing over here?
x minus
Good, x minus 5, x minus 5. Now, I need to be careful with my algebra skills. What do I have to do with that 4 in the top? Distribute, wonderful. So I have 4x plus 4 all over x plus 1 times x plus 5 times x minus 5. Plus, what do I have to do with this 6? Distribute, wonderful. So plus 6x minus 30 over x plus 5, or sorry, x plus 1, x plus 5. Doesn't matter the order. They just have to be the same. X minus 5. The denominators are the same. I have been successful so in obtaining the least common denominator. So I can bring them into one fraction and start combining the numerators. What is 4x plus 6x? 10x, wonderful. What is 4 minus 30? Negative 26, perfect.
So where'd you get,
I had to distribute that 6 in the top. All right, guys, we could factor the 10x minus 26. Like there is a GCF of 2 that goes in there, but we don't need to because it doesn't cancel with anything in the denominator. You only need to factor when you have a factor in the denominator that matches. Otherwise, you can leave it like that. But we do need to talk about our restrictions. What would be our restrictions?
-1, -5.
Perfect. Charlie just gave them all. -1, -5, and 5. Because those would make the denominator equal 0. Awesome. All right. Example 8, the last and final one. On your own, see if you can determine what would be the least common denominator. Okay, check up here. Did you say c plus 2, c minus 2? Hopefully you did. If not, change it. That is the least common denominator.
Like, can you just multiply one side by like negative?
Oh, that would be so nice, but we can't because these guys are connected as one number. Now, I'm going to multiply this fraction on the right by c plus 2 over c plus 2. I'm going to multiply the fraction on the left by c minus 2 over c minus 2. I need to be super careful with my distributive property. Distribute the 2c, and that gives me 2c squared minus 4c over c minus 2c plus 2. Minus, I need to distribute this 3c into 3c squared plus 6c all over c minus 2c plus 2. Guys, what did I say to put around the terms when you're subtracting? Parentheses, awesome. And if I use parentheses here, what do I need to remember?
The negative sign.
The negative sign, awesome. So I need to distribute here, which if I kind of combine this all together, I'll have 2c squared minus 4c minus 3c squared minus 6c. I'll say that's probably the most common mistake I see is we forget to distribute that negative over c minus 2c plus 2. Now I combine my like terms. So 2c squared minus 3c squared is equal to a negative c squared. Negative 4c and negative 6c give me negative 10c all over c minus 2, c plus 2. Now I could take out a GCF of c, but that doesn't help me because it doesn't cancel with the top and the bottom. So this is great as an answer. I just have to add my restrictions. What would be my restrictions? Nice. C can't equal 2 or negative 2. And that would be my answer. All right, you guys are going to be given about 30 minutes to work on the first homework. I've given you all the answers so that you can check as you go. I would strongly encourage you to ask questions while I'm here walking around. If you're stuck at 10 to 11, we're going to finish these notes, which go along with the second part of the homework. If you need paper homework, I do have paper homework up here under the notes, and you guys can go ahead and begin.
I take the quiz.
Yeah, I think you can. Are you ready? You studied all the cases and stuff?
Oh, I'll just check.